Hi everyone, and welcome to today's session. So today we'll be talking about an output parser that I've recently developed. It's called parse YAML. So parse YAML basically asks the LM to output in a YAML format. And in the YAML format, we will then convert it to a Python objects and Python dictionaries where you can use to access your data. So it is very cool because it is a form of structured output. You can get the large language model to return very specific data types like integer, float, string, bool, list, dictionary, date, datetime, time, the UUID, decimal. So basically, these are the types that Pydantic supports. We can also do enumerate. Okay, we can also do all this none, any, union, optional, which you can mix and match data types. So if you don't specify any data type, we will treat it as any data type. And if you compare it with structured outputs from other stuff like Gemini, it's much more limited. Like you can only do like maybe object, array, string, integer. Of course, it might be a little more robust because they have fine-tuned it directly on the way they want to do the output parsing. But if you use ParsYML, you can do it not just for Gemini, OpenAI, you can also do for Claude, you can do for Llama, DeepSeek, and so on. So I've tried the prompts on many major LM providers and it's working, at least for the simple ones. For the complex one, it depends on how well the LM is trained on the ML data. So yeah, this is just an improvement to my earlier version of strict JSON. So this is the strict JSON site. So initially for strict JSON, I output it as a JSON. And I realized that using JSON may not be the best because when I output large code blocks, which is going to be the meta for coding agents, the backslash quotation marks tend to trip the LM up and the code block does not get passed properly. So with YAML, you can do everything as one single code block without the need for backslash. Okay, because there's a multi-line parser. Okay, so this is really quite cool. And yeah, we can see how this works. And let's take a look at how we can code this out. So first, I'm just going to run the example notebook. You can also get this at the strict JSON GitHub. You can go and get it here under parse YAML. So this is how we do it. First, we run it. Okay. And then let's say I'm going to use Google Gemini 2.5 Flash. And we just define our large language model. And the way we define it is just define a system prompt, a user prompt, okay, and other parameters you're going to pass it into your model. So you can use any model you want. Here I'm using Gemini, but you can also use others. Okay, I'm using Open Router, which allows you to route to any LM provider that they provide. So like any of the above here. So you can plug and play your own LM. Just make sure that you just put in your system prompt as a string, user prompt as a string, pass them into your model, okay, and then get the response for your model as text out of the model. So let's see. And we also have a async function if you want to do async. That means like you want to do things asynchronously in the code where different processes can run at the same time. You can use async function, just define it in an async way and await the model. Right? So everything is the same as the sync version. So we do have two versions for ParsYML. One is the sync and one is the async. But first, let's see how it does the job. All right. So ParsYML, you just call a system prompt. You call the user prompt. Okay. System prompt is like your overall instruction to the model. The user prompt is like what you want the model to do. And then the output format is the key thing. Okay. Because in the output format, we can then specify what are the fields that we want to receive, the names of these fields and the types of these fields. So like the name, I want it to be string. In the date, I want it to be a date. The participants, I want it to be a list of this data structure containing name and age. So you can see that this populates a list of participants with these two parameters in the dictionary. So let's run this code and we can see that immediately we can convert this output format into a pretty YAML format that's very concise. Can you see the number of characters here? Okay, so let me just show you, if let's say we were to do it in a normal schema, like JSON schema or YAML schema, it will look something like this. You need to define your model and define everything, define the additional properties, put the required stuff. So can you see that this is like humongous? This is huge compared to what we feed the model. We just feed the model this. Look at the amount of token savings that you have. And because you see a lot of stuff like format, title, type, all this is not very necessary, or you just need to, just do like this and the LM would understand already. So, we save so many characters just like this. And this is the YAML schema. If I were to show you the JSON schema, it's even worse. JSON schema is, because of all the brackets and everything, JSON schema is much longer than this. So this is how the LM would process. The LM will get the results here in this format. So you can see it's returning the name as a string, the date as a date, participants as a dictionary. So this is how YAML expresses all of this. And this is a list. So you can see YAML is very, very concise, right? The only issue is that sometimes LMs may not know how to parse in this format, but most leading LMs already know how to do this. So this list of dictionary is not too much of a problem for this case. All right, and then we pass it, and out comes the dictionary. Can you see this? So let me just show you something that if let's say we want to do something like, we want to say the name of the birthday event must contain only 3 words. You can do a description, and then you can comma and then put your data type here. And this is what will happen. We will have to contain only 3 words over here. And in the schema itself, you can see the description of your name is now contain only 3 words and the type is string. You can even do stuff like this. So you can see the output is now 3 words only. You can do stuff like this. You can do union of string and integer, which means like, let's say if you want to, if you're not sure whether the return is a string or an integer, you can do this. So the data type is either or, is either string or integer. You can see this is how it looks like in our small, concise YAML format. And when we go to the data type, you will see that it's now any of string and integer. And you can also do something like this. Okay, so the output here is still a string, all right? You can even do something like this, optional string, all right? Which means if I don't want the name, I will output nothing, okay? So over here, you output something, okay? And the format here is either a string or null format, right? So if we change it over here, if birthday is for Alex, output nothing. Yeah, something like this. Then we will see that because this birthday is for Alex, it should output nothing, right? So over here, you can see that this is the type of string and null. And let's see the output. The output is nothing. All right, this is very useful because if we were to do something like this, you saw the result in a res, and then you can see this res here. You can put res name it later on. Okay, wait, sorry, name is small letter, which is none. Okay, then we can let's put like if this print birthday party is for Alex. Something like this, we can actually, oh, wait, if res name is none. Yep. So you can do something like this, if let's say you want to output nothing, let's say if you're doing an agentic pipeline, we can just say, ask it to, output null if let's say it's not fulfilled. If some criteria is not fulfilled, we can then, do some if loop on that error and then we can print out something. So this is very, very helpful by doing stuff like optional. And, in case you find this very complicated, I actually implemented an easier version to do this. So you can just do string and this brace here, this pipe operator and none, and this is the same as doing optional string. So this is like how we do it. And you can see that over here is either string or null, and over here is birthday party for Alex. Yeah, we should output none. Oops. Yeah. So sometimes output nothing they don't accept. So prompting matters a bit. So you can do this kind of thing, string or none. All right, and then you can see over here. So yeah, this is more or less like you can do a description and you can do a data type here after the comma. If you want to be extra safe, you can even tell the LM that it's a type by putting this type over here. And yeah, this will basically it will do the same thing actually. It's just that for the LM prompting, they will know that this is a type. Okay, but in the schema itself that we use it to validate is the same. Okay, so what's the benefit of ParsYAML? ParsYAML converts your output format here into a Pydantic model. And using Pydantic models validators, it will validate to make sure all the fields are as what you require, like over here. So yeah, this is more or less how it works. I'm just going to change it back to this string here. Okay, so you can see like this is the how it's done. All right. Let's move on to the next part. Do you have any questions before I move on? Like, is this clear? Like how to do this? Yeah, I think the output format is just like a dictionary. Like you just put a key name and then you put your output type. Yeah, just like that. So in PassYAML, there's a big upgrade compared to straight JSON. The big upgrade is that it accepts any Pydantic model. All right, so you don't have to use this output format. I personally like to use the output format because I find that it's very, very concise and you don't have to, import a lot of stuff from Pydantic. But if you so want to import stuff from Pydantic, we do have an option to cater for that. You can define your Pydantic model here, like this is class participant with string and integer for name and age. And then you have a class calendar event for name of the calendar event, date of the calendar event, and the participants. So you can see that this is the model that we import, okay, and it's matching this entirely. You can see this takes so few words, right? But if you look down here, if you do a Pydantic model, look at that. You have to do so many things. All right. And yeah, let's just do a debug equals true here to that you see the output. And you can see over here the same thing. System prompt is you are a helpful assistant. Did I put wrongly? Oops, yeah, I put wrongly here. Generate a birthday event for Alex. And the Pydantic model, we put this calendar event that we've created. And put in your LM here. And put debug as true to see like what's going on. And you can see we have generated this Pydantic schema, which is, if you were to put in a JSON schema or YAML schema, it's going to be this long. It's going to be this long, huge thing in your context. We have concisely represented it like this. And this is like, let me just zoom in a bit. This is like huge savings. You look at this, look at the number of characters that we use here. Huge savings in the LM context. And the schema that we generate is like that. And yeah, you can see that this is the output. And then we pass the output and we get the dictionary back. Right, so very, very useful because you can do this for a lot of different formats you want. And this will be very helpful for your subsequent pipelines as well. So, as if this wasn't enough already, we also allow you to do description of your fields. Just now I just demonstrated. You just need to put your description at the start and then put a comma and your data type, and there you go. Like you have your description. So like name of birthday party, any date, name starting with A, age between 5 to 12. All right, so we can use this to generate, and yeah, you can see that you have everything here. Just to be clear how this works, we can also show you the debug screen. Just put debug as true. And you can see this is the concise YAML format that is used. This is the YAML schema. You see all the descriptions have been neatly created for you. Yeah. So yeah, and then you can see the output is like that. And then once we pass it, we get this. Very, very cool. And you can see stuff like, quotation marks, never backslash and everything. All these are moot points because YAML doesn't really need that. As long as you are after the quotation marks, everything here is a string. Or like the data type here, if it's like 7, it'll be converted to a number. So it's very, very flexible. You avoid a lot of the pitfalls of JSON. Yeah, I've tried this for code blocks, for huge report chunk blocks. YAML is better, much better, right? So you can see this is like how we do this. In fact, for the earlier case where we import our own Pydantic model, you can also do the description. I think we'll have we can do the description like that in the Pydantic model. You can even do extra stuff like check the pattern to make sure it starts with A greater than or less than. Okay, all this actually won't make it into the prompt. Okay, I can show you the prompt. All this won't make it into the prompt, but because of your description here, the LM would know. So like here, starting with A, it would be like here. Okay, we won't like do this maximum minimum inside the prompt. This is just in the prompt. And that's enough for the LM to know already. You can see this is the YAML schema that we generate. And like over here, you have all these patterns and everything that the YAML accepts. And then we have all this here, and we get the output. So very cool. You can just output your own Pydantic model. And then from this Pydantic model, we will convert this directly into, a YAML schema that can be used for parse YAML. So, if you are very familiar with Pydantic models, it's literally just a plug and play of whatever Pydantic model you use, put inside parse YAML, and you get the output response. Okay, this works great for code blocks. So if you need to use code blocks or very large chunks of report blocks, this might be even better than the structured output parsers that I use by OpenAI and Gemini. All right. let's move on. So async method is similar to sync. It's just that you need to await your method because it's a coroutine for async. And then you call the async LM here. So we can just call this and everything's exactly the same. So you can see if we were to do this without the output parser, it'll be very, very difficult to get all the different components of what you want. But here it's so convenient. You can just do like that. And you know, the great thing is this output format, I invented this. I like it a lot. Like, look at how concise this output format is compared to, you know, doing it in Pydantic like this. You know, eventually everything would be Pydantic. Yes, I've created like 300 or 400 lines of code to convert the output format to a Pydantic model in PyYAML, in ParsYAML. Um, but I think it's worth it, okay, because Pydantic is really quite powerful and you can use it to validate a lot of things. So yeah, it's really very cool how you can do this just from using a Pydantic, just from using this output format. In fact, if you still want to use Gemini structured outputs, not to fret, in ParsYAML, there's this thing here. Oops, I'm just testing something here. In ParsYAML, you can actually convert the output format into the JSON schema. So you can see, like, let's say this is the one that we were talking about earlier. We can convert schema to Pydantic, and you know, you can convert schema to Pydantic and you put this output format. And what you will get is you'll get the model itself. This model is actually a Pydantic model. And then you can, over here, you can, you know, you can output the JSON schema or whatever schema you want that Pydantic supports. You can see this is the JSON schema. Okay, which, you know, it's so lengthy and everything, but you can plug and play this into like either OpenAI or Gemini. You can put that into here, into their JSON schema for structured outputs. So, I mean, if you don't want to use ParsYAML, but you want to benefit from having a very concise output format converter into a JSON schema, yeah, you can just use this function, convert schema to Pydantic, right? So just to give you a clue as to how efficient this is, like this JSON schema length is usually about like 902 characters. Okay, of course here the model is a bit large. You know, you can, the model name is huge. You can compress it a bit more, but you know, maybe 500 characters if you compress. I'm not sure. Yeah, you can compress these large characters. But if you look at the YAML schema, there's this function called convert Pydantic to YAML, which converts this this Pydantic model into very concise schema. You can see the number of characters is like 138 characters, and this is 900. All right, so there's a huge savings, and the savings only become bigger as your model becomes more complicated. So over here, you can see this is a huge benefit of using a YAML schema. And yep, just in case you are wondering, like, hey, yeah, just now you mentioned I need to prompt a bit more, right, in order to get the YAML to work. And yeah, this is the prompt. So in the parse YAML itself, you can see that we have a prompt here. And the prompt basically asks the model to update the values of the YAML schema. And this is the concise YAML schema you saw earlier. Okay, and I give it some hints like this is how to do list, this is how to do dictionary, this is how to do multi-line output, and these are all the output, how you output the appropriate values that meets the data types. Make sure you output all the keys. Okay, if any keys contain non-alphanumeric type characters, quote it. Okay, this prevents like a percentage from being the start of the key, which means different things in YAML. Okay, so we had to quote it. Right. So yeah, you can see this is the extra context. We can just do a quick check of how long this is. This is about 457 characters. Some LMs don't need these hints, some do, right? So if the JSON schema is more complicated, this will definitely win like a normal one. In fact, you don't need it to be too complicated. You know, we can just do a sample one with a simpler model schema. Let me just show you. Yeah. Output format. Let's just do something like that. Yeah, very, very simple, name and age only. Yeah. You can see this is the JSON schema, 243. Okay, this one maybe bad example because like this is 457. Yeah, but you know, if you were to do like, I don't know, name, age, school, and then maybe like hobby. something like this. Yeah, okay, over here, this is normal JSON schema. Is this? Okay, because there's no reference here, so there's no long names. But you know, if you were to do something like this, and then if you compare it to like the YAML schema, it is actually very short compared in comparison. It's just that, you know, this caveat is that there's this prompt that is needed to make sure that the LM knows YAML properly. You know, if the LM does not need to know YAML, then you can just omit this whole thing and then it'll be much shorter. Okay, but there's a caveat. This is still the prompt that is needed. All right. Okay, I'm just going to delete this. This is a bit more technical because I think you all want to know how the YAML works, right? So I spent quite a few days trying to figure out how to get it to work. And yeah, this is the approach that I came up with. All right. All good. Okay, I just
I was
going to
gonna
show.
ask
Yep.
really quick,
Yes.
just a quick question. So for the under the hood, the actual parse YAML function, the prompt that you use for it, how does it compare exactly to the strict JSON prompt the strict JSON function and the prompt that you use for
Okay.
that, like lengthwise, because you're running that function every single time you prompt the LLM. So I'm just curious what the token usage looks like.
Yeah, strict JSON is a little bit more concise because there's no need to prompt it so much. The models understand JSON quite well. Yeah, so as I mean, I was half a mind thinking about, you know, whether I want to go back to JSON with Pydantic or something else. I decided that I'll stick to YAML because JSON is really quite bad for code blocks. This is the prompt for JSON. Update values enclosed in this. Update with the template beginning with this and this. Ensure the following keys are present. Yeah, so it's I think it's not much of a the length is not much. 239. Yeah, so yeah, it's not that much. Yeah, but strict JSON does have a prompt at the end. Initially, it's just this two, but I realized that you still need to put the key as well. Yeah. So you can see that like stuff like output keys and everything, important to prompt the LM so that they don't forget to output it. So in past YAML, the prompt is very similar. The past YAML prompt is like make sure you output all the keys. Yeah. So yeah, it's just that we have this additional few short example to tell the LM how to do it.
Okay, yeah, that makes sense. Appreciate
Yeah.
it.
So already this is already quite concise already. I try to make it as little as possible. And I think this is quite I mean maybe we do by character counts doesn't do it justice because a lot of this actually would go into one token. Yeah, you should use token counts instead. I just want to say that like the amount of gain that you have here is actually minuscule compared to um your gains. I mean the context length increase here is minuscule compared to like how much better the LM can output stuff without the backslash quotations and backslash brackets, which like broke a lot of code when I was passing with JSON. Yeah, so YAML is really very good for this kind of long context blocks. Yeah, so a little bit of context overhead, I think is justifiable.
Right, right. That was my second question. The context is is an investment into the performance of the output. So the output still overall is much more efficient than the JSON
Yes,
output.
yes.
Is that
Yeah.
right? And token usage and token output.
Yeah, I think in terms of token output, YAML is definitely better. Yeah, if you look
Okay.
at the token here, this is the output for YAML. Yeah, if you were to convert this to JSON, it'll be more. I can just show you. Like, let me just ask GPT to convert this to JSON. You can then check convert this to JSON, and there we go. This is the JSON one, and let's just do a quick comparison of the length. This is JSON, about 134. Okay, of course there's a 79. Okay, maybe we have to be a bit more fair. So wait, dot remove, dot replace. Yeah, something like that. Yeah. And maybe also replace the tabs with blanks. Okay. Actually, I don't think we need all this because it's already. Oh, I'm removing all the blank spaces. Yeah, I think it's still 99. Yeah, so you can see like just like this, there's already a huge um gain. I mean, if you were to talk about code blocks, the gains are even more because code blocks you need to backslash. So let's say if we were to do like a code block here, and then like okay, maybe let me just ask the LM to generate me a code block. Yeah, I mean I might as well, right? Since we are having so generate mini code to output the first three primes. Okay, then maybe we have the output format as uh, rationale. Describe how you would write the code. Then you put this in string, and then you have the code itself, code in Python. All right, so something like that, and yeah, we can just output. Uh, Perhaps you forgot a comma. Oh yeah, I forgot a comma here. Okay, so we have the output here. Okay, and then we get the response. Is this? Okay, in fact, actually, we don't really need the GPT to do the difference because the response here is in JSON format already. Like is basically like all the slash ends and everything. Yeah. The code here, you need to if there's anything inside the code that is in the quotation mark, you need to backslash it. So maybe output to print out the names Mary and John, something like that. Yep. So we can see the backslash quotations. You can see over here. Code. Over here they are smart. They avoided the backslash by doing a single quote. Okay. So something like this, if you were to do it in JSON, very likely, sometimes you might have difficulty because the output here would clash, and then you need to do a backslash. Yeah. So if we were to use this and just compare this description here. This is how it works for ParsYML. You have a multi-line index, and in multi-line index, you can do everything in free text, no back quotations and everything. This is the the best part of ParsYML. So this is the output for YAML like that. We can just take a look at the length of it. So we can take a look at the length of this 305, and then we can take a look at the length of this, which is the JSON format. Okay, so here, because how I put it, there's no back quotations here, so you cannot really tell the difference. Yeah, but let's say if you have a lot of back quotations and stuff, which is very common in code, you would have a much shorter YAML output. Yeah, so anyway, this is just for your curiosity, like how it compares. Yeah, did that already, like
Yeah, it gives me a good idea. Thank you.
yeah. Okay, so okay, I'm just gonna delete all this. Yeah, we don't need all this. Yeah, so yeah, you can use this kind of structure outputs for many different things. One is like, you want to have an invoice here. Invoice can also be in image form. Later I can show you how you do it in image. Right, so you have an invoice like that. You put the invoice in your user prompt and you extract the details. Let's say you have certain output formats you want, you just put the name and the data type here, like that. Okay, and you can even have line items that repeat this. Yeah, you can do this and you get everything extracted out. Look at this, like invoice number 1234, invoice date is 23rd March. You can also do in date time in Python as well. So you can see here 23rd March, 1234. Maybe you look at the final one. Total price is 118.25. It's here, 118.25. Everything that you need is all here. So this is one of the cool usage of structured outputs. And you can use this for most models. So the ParsYML. You can also use Pydantic models. So everything that we saw earlier, like that, Okay, like even the description like text amount, total value for invoice, all this converted to a description field in what do you call that, in a Pydantic model. And you can run this and you should get pretty much the same thing. Yeah. So it accepts Pydantic models, and it will extract out the different kind of data types that this ParsYML accepts, which is the list of data types I talked about at the start. So it's very, very flexible. And for the type checking, it will do whatever additional checks you put in your Pydantic model as well, like, the patterns greater than, less than. So very, very versatile. Okay. So you can even ask it to, extract entities from a report. Let's say this is a report about some studies about nuclear safety in Singapore. So it's very long text. We can ask it to extract, okay, the entities from the text, a list of strings, a sentiment. You can ask it to do multiple choice by asking it to do a enumerate, like what's the tone of it? Is there any mention of DeepSeek? Okay, if yes, then put, if not, put none. Summary of the paper, write the code to print out entities, write latex code. Here actually is not really the norm for use cases, but I just wanted to show, you can do code blocks and latex as well. So you can see the output here. We have all this stuff like Singapore, Lawrence Wong, SPH Media for entities. So you have a off-the-shelf sentiment extractor. Very, very useful. What's my sentiment? Whether there's news? None. Okay, there's no news. The summary of the article here. Okay, you can even put like, one sentence of no more than 10 words. Yeah, so this, forces it to, check whether, okay, here we don't have a hard check to check the number of words, but, LM understands this quite well. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so you can see this is the summary. You can like verbally prompt it here by putting a description. So it's very, very cool. All right, we have the code for entities here, and we have the latex code, which you can just copy and paste into a latex document and it should run. And actually, latex was one of the main reasons why I created ParsYML. I tried to convert something to latex, and I tried to output latex using ParsYML. This was for my deep research for archive papers. Me and Dylan, we created an app that enables you to do deep research. And yeah, basically I tried to output latex code to generate the PDF. And because in my old strict JSON, the backslash actually meant something. So like for code, I actually had to, remove certain backslash, and it like backslash T was converted to a tab in my old strict JSON. So like this slash T will be converted to a tab character, and it essentially like ruins the latex. So with ParsYML, no such thing, because the whole latex code is now in a multi-line block. Very clean. Everything comes out neatly. Yeah. So I love it. I actually love ParsYML for code and this kind of huge content blocks. Very, very useful. Right. So we can do even more advanced tests. Like here, we can do multiple data types. You can see we have a code here that enables us to, like give me 5 names on a topic about weather, and you have 5 names here: sunny, breezy, cloudy, rainy, stormy. Name and the meaning in a dictionary form. All right, Chinese meanings, dictionary form. A lucky name or number, you can do a union list int string. Here, actually, it's a list. You don't really need a list, but you can just do a single number. But I just want to show you can nest the data types like that. All right, Python code. Okay, you can mix and match the code. The sentiment, you can do a enumerate, and you can even do like 1 to 5 scale. You can enumerate here. So very, very versatile. You can see like if you put this in a normal output parser, it will typically break. And I think OpenAI doesn't support stuff like this. It's too complicated. Yeah, but you can use ParsYML to do this. Right? So this is the async version, same stuff. Right? This broke some code for my like parsing that I tried for some documents. And like stuff like a dollar sign at the start or like a percentage kind of broke the ParsYML. So I've made it even more robust last week. I made it such that you can pass special characters and it works. You can see this is like if you want to take a table and you want to extract out the key value pairs for the table like this, like what's the day, what's the percentage precipitation, and what's this thing here, you can see that it works. Yeah. So really cool. And yeah, I explained how it works under the hood. So yeah, this is how the parse YAML can actually help you with getting your output data types and so on. Like before we go to some like live code, I just want to show you how to do the multimodal part. So multimodal part, you just need to go to strict JSON utils, import the image parser and image parser async. And then for a sync LM, just put a decorator here, image parser. What this does is that whenever you have this kind of thing inside your prompt, double angle brackets, I will do in the back end some code to convert this to extract out the image from this path on your computer and put it into the LM, right? You can also put URLs inside, right? So this is a very, very cool way to do things because this works for the OpenAI kind of config. I also have another version for Gemini, but I didn't put on strict JSON. So this basically takes your user prompt, and then if you have all these angle brackets, it converts them into a form that the LM can understand for the image. So let's take a look how this is done. So async is the same way. You just use the async parser. All right. And like, let's say I was doing a Pokemon kind of thing, like this is the Agent Joe Pokemon stuff. You can do the two image URLs. And then, this is how it looks like. I just displayed for you to see these are the two images. And now, if let's say I want to say like you are a friendly assistant, describe what happens, then you put in your image URL inside either your user or system prompt. Um, Actually, no, you don't put in the system prompt. You put in the user prompt because only the user prompt will be processed for this. So we put in the images in the user prompt here. And what you can see is you can see that this image here, you can then ask the LM to describe the image. So like here, describe the first state. State 1, players in a cave on the right side of a path segment and so on. State 2, player same cave is unchanged from the previous state. Okay, move slightly to the left. So he thinks that is a bit unchanged. So sometimes the vision model can make mistakes. So over here, thoughts the player position has not changed. It Let's try again, all right? Sometimes the model thinks that it doesn't work. It doesn't move. So over here, the player seems to be navigating. Okay, and over here, this suggests minor movements, all right? So yes, so this is actually a problem that I face in a Pokemon playthrough as well. The LM itself is not too sensitive with respect to position, right? But out of all the LMs I tried, like Gemini Flash 2.5 Flash is still one of the better ones to to know the change of position and so on. So you can see this is rate's position hasn't changed. Okay, this is right. Pay particular attention to the tiles of the game and the position of the players. We need to prompt it like that, and we can see how it works. And you can see the player has moved one step to their right. See, finally, after I asked it to take note of the position, it knows that it has moved one step to the right. So sometimes you need to prompt it. But the point still stands. LMs are typically not that great for position navigation. All right, so we have to use other tools like, do like some CNN to check the tiles or, just use some form of traversability map that the game provides and so on. Yeah, so this is a weakness with current LMs, right? The position information, right? Although DeepSeek OCR claims to have, done the bounding box right, no, theirs is through lots of fine tuning with the documents. It's not natively good. All right, so this is how you do for an image with the URL like that. Let's try an image that uses a file path. So like I have a file here called AI electricity. And you can see over here, we have this output the text on the image here, and the image is given by the file path. And we output image text of all the words on the text and the image description. Let's take a look what happens. And you can see that it's processing. Oh, what's happening? Oh, this is new. Okay, let's try again. Okay, yeah. I don't know why it failed just now, but yeah. So this is the AI is the new electricity, and just as electricity transforms and so on, you can see this the text. I like this text a lot because I believe that AI really has the potential to transform industries, and I like Andrew Ng a lot. I'm a huge supporter of his courses, and yeah, recently he came out with an agentic AI course which I really like talking about how agents should be in a pipeline and not like a free flow kind of you let the agent decide any action. kind of thing. And you also need the agent to be heavily validated by certain validation cases so that you know the agent is working. Yeah, so I like his approach to agents. And yeah, this is typically like how you would parse an image. Any questions for this? Okay, I think this image parsing is really very powerful because it enables you to do a lot of things with this. So now let me just, we're just going to start a notebook from scratch. Just going to do like this. I just want to show you, like sample coding notebook. Do you have anything you want to see coded? If not, I'm just going to do any random stuff.
Off the top of my head, sorry, off the top of my head, uh, it's a good use case. Can you build like a miniature, like a very miniature, like a planning generator? You know what I mean? Like a plan generator or an idea
Mhm.
generator, something along those lines. You know, but like very small and self-looping. Nothing crazy.
So basically you do a plan and then you expand on each bullet of the plan.
Yeah, you generate the idea and then you kind of
Yeah.
refine the idea and you just
Sure.
do like a little loop.
Sure. Okay, so let's do your plan generator, right? Plan generator to do refinement of plan and make plan more specific. Okay, so first step, what we need to do is we need to come up with like an idea of how to do this plan. And so first is like get LM to come up with the backbone of the plan. And then after that, next we need to get the LM to output details of the plan within each part of the backbone. We keep it simple like that first. Of course, you can use tools and stuff to do more things later. Let's just use the first thing. We need to import our from check import pass YAML. Pass YAML is sync. Actually, we just need pass YAML because we do everything in sync right now. So first up, we just um do pass YAML to do system prompt would be generate a backbone of the plan to do the following user intention. Okay, and then the user prompt would be, I don't know, what do you want? What plan do you want generated?
Let's start with, I don't know. I feel like LLMs are pretty good at recipes for some reason, like cooking recipes,
Mm-hmm.
especially when it comes to like getting into details and planning out the different steps. I don't know why, but they just happen to be really good at cooking, I guess.
Okay, so do you want something cooking?
Yeah, like a recipe generator or like a recipe planner.
Okay, yeah. All right. So if you want to do cooking, then it'll be a little different. I think what we can do is, first we get LM to come up with possible recipes given your ingredients. Okay, that's one. And then next we get the LM to expand on a recipe with various steps. Get LM to come up with steps for a recipe, and then the last one is get LM to expand on each step for the recipe. So these are the three pipelines that we want. So first is generate possible recipes given user ingredients. Okay, so over here your user prompt would be your ingredients, all right? So and like let's just ask, give me 10 typical ingredients you can find in a fridge, right? Actually, we can also use PassYAML for this, but let me just, okay, let's put this here. All right, these are my ingredients, okay, and then recipes, type list, generate maybe 10 possible recipes. So, oh, wait, there's no output format. Unable to pass out. Oh, I forgot to. Okay. OS is not found. Okay, so we need to import the OS somewhere. Okay. Model is not defined. Oh, okay. Because I just copied this just now, I didn't copy the first part here, which is the model. All right, no problem. Yeah, it's just the LM. Okay, let's just see. So now we should have the recipes here. Yeah, these are my recipes: cheesy scrambled eggs, deli meats, cold cuts, and so on. Vegetable and omelette. So these are my recipes. So if you like, you can also print out the recipes. List has no keys. Wait a minute. Print this name. Okay, so over here I realized something. I probably shouldn't just let it free flow. We should just do something like name. Name is a string, and then maybe the next one is a instructions, summary, or like description. String. Okay, we don't need the instructions right now because we will generate that later. So this is the recipe. And what's happening here? We have this thing. Oh, I forgot my close bracket. Okay, yep, like that. Unable to pass expected. Okay, I think I missed out something here. Name is string. Okay. This is a good example of a use case. You cannot do a type for this. You have to do it like that. Yeah, this is just one of the quirks for this nested list. Okay, now we should have it. And we can see these are my recipes, name and descriptions for each of them. So either cheese, scrambled eggs with veggies, and so on. So maybe the next one is, we could rank them by nutritional value. So what we can do is, okay, we take this whole thing here, rank each of these recipes by nutritional value. So what we can do is we can have the output recipe, we can have the name, we can have the nutritional value. And over here, we can have it to be an enum of like 1, 2, 3, 4, 5. Right? We can have a nutritional value. And maybe we can do an explanation for nutritional value first. Because, we want to make sure that. So yeah, we can rank each of these recipes by 5 is the healthiest. So yeah, we can do another one like rest2 is this, and then the user prompt here would be the rest recipes. Actually, we can just put the initial one here. So these are my recipes that we can use, and then we can see invalid code. Okay, what's happening? Did I do something wrongly? Okay. Invalid input. All right, that's the weird thing. Okay, this hasn't really happened before. Did I do something wrongly here? Recipes. Oh. Yeah, because I used the rest, but I didn't convert it to a string, right? So yeah, we probably should convert this thing to a string for the user input. I probably can implement this in PassYAML also, make to force the input to a string. Yeah. No, actually I shouldn't. Yeah, because sometimes your user input might be a list. Okay, so here we have the output for rest2. You can see these are my nutritional values here. 5, 5, 4, 4, 3, 2, 2. Okay. So, what I want to do is I want to basically, from this, I want to rank and then get the top 3 ingredients. All right, here I could just do a basic sort and so on. But I'm just going to use like PassYAML for it just for showcase. Given this data structure, recipes, print out the top 3 name and description and nutritional value. Print out the top 3 indices based on nutritional value. 5 is the healthiest. Okay, so we could just print out the top 3, and these are my inputs. And here, output will be the code, how to execute this. Okay, and yeah, let's just see how this works. So now we have the recipe city. We want to get the code for it. Okay, and I missed out some like that. Okay, so we can see. Oh, I forgot to put the rest too. Okay, so this is the. Okay, let me see. So let's see. Output code to extract. Okay, let's try this again. Yeah, I hope it works because I never tested this before. So, let's see the code here. So this is the recipes. Assuming recipes is a, okay, let me just print this here. Okay, so assuming the original snippet is broken. Okay, so it looks like they didn't get is my rest tool broken? No, it's not. Okay. Oh, because they didn't get the data structure, is it? Given the user input. Okay, so maybe you can put given this variable recipes, output this. Okay. Yeah, I guess we could do something like that. Yeah. Okay, so let's see the code. Sorted recipes equals to recipes. Okay, I need to take out the recipes here. Okay, so now they will know the data structure of recipes and they can use this to extract stuff. So recipes equals to this, sort recipes by nutritional value. Okay. From user input. Okay, let's see. Okay, something like this, but all these are not okay. Maybe you need to prompt it better. Use the recipes given by user and okay, something like this. All right, let's see. So you see there's a bit of prompt engineering involved here, which is all right, I guess. Yeah. So let's see how we can do this. Error code. What's happening? Okay. Oh, now they're hallucinating this. Yeah. Okay, so maybe it's not a good idea after all to just pass this whole data structure inside. Okay, I think what we can do is like this. Okay, let's not do the code part. Okay, I'll put the top 3 recipes by nutritional value. And then, we could just output like that again.
Well, let me ask, is there anything wrong with combining res 3 and 2 into one single prompt? Just so that we can minimize the...
Oh, yeah. Something like that. Yeah.
Yeah, that way we don't need to do a res 3. We can just do res
And
2 and it'll
output
give us...
the healthiest. Actually, just output one. Yeah.
Yeah.
Yeah. Yeah, we can do something like that. And let's try it. Yeah. Sometimes it's a hit and miss. We have to see. So over here, the healthiest is this deconstructed chef salad. Okay, and nutritional value is 5, and that's correct. All right, so we can have this, and we can just take this and we do a parse YAML again. So you can see many parse YAMLs are actually enough to do a lot of things. So like what we can do is you can now output a skeleton plan for cooking this recipe. So over here, the input would be, we can just do f string. Yeah. So the recipe would be rest to healthiest recipe. And then the ingredients would be ingredients. So that we still let the LM know about the ingredients, and output format would be equals to skeleton plan. And this can be in a form of a list, or just put list like that. Yeah. Okay, so now what we need to do is for each of these items in the plan, we need to elaborate it. All right. So okay, so that we can do a lot. I mean, actually, we can do everything in one go. Like, I'm sure the LMs can handle all this, but I just want to show how we can do this if we were to split it up like that. So we can have the overall plan given here. Overall plan can be in rest tree, which is this one. Okay, and then you have your ingredients because I think it's still needed. And then you could have a detailed plan for each part. Output the detailed plan for each part of the. So over here we have a skeleton plan here. Okay, type list. Okay, so we can do something like that to get our details. Make it such that there is quantity given and time inside the plan, and make it friendly enough for a 12-year-old. Something like that. Yep. Let's just run this plan, and then we can get the rest for, which is here. So we can have this detailed plan for each part, and you can see. Okay, so over here, look through your fridge and pantry for this, deli meats and so on. Wash and chop vegetables. Okay, then slice eggs. Yeah, so I think this is not very instructive yet. Okay, because we want to also mention how to do it. Okay, we can add more prompts to it. Be detailed and make sure every step is explained, including how to slice and how to cook. Something like that. Yep. So now we're making a salad. Yeah. So what you can do is actually you can also do it such that you expand out each part of the plan individually through individual calls. Okay, and then you just put whatever you have earlier on in the user context. Oh, wait a minute. Expected string instance dictionary found. Okay. What's this? Oh, it became a list of dictionary. Okay, so we need to specify list string instead. All right, because if you don't specify this, it will be list any, and here they made it to a list dictionary, but we want it to be a string. Yeah, so you can see the data types matter a lot because in the downstream processing, you will need all this. So yeah, I think we have all this part one, part two. and so on. We can just print this out. All right. Now we have everything that is like here. Part one, quantity. First, look through your fridge. We have this. Okay, then we take all the veggie and fruits, clean them. I think this is quite detailed. Yeah. So, I mean, you can customize it according to how you like it, but I think this is pretty much like basically like how it's done. And yeah, let's just see this done for like something else. Okay, let's use other ingredients, all right? Let's see. Um, why not you all come up with some ingredients?
Well,
Are
I'm
there?
curious, what kind of ingredients do you have over in Singapore? Do you have anything home specific? I'm curious.
Mm, I have. I typically eat tofu, like eat tofu. Like is my stuff. Like I also have other stuff like broccoli. I mean, I don't really eat meat nowadays, so pasta. I guess rice also like mushrooms. Yeah. Do you want to come with some ingredients? Because I know what I'll cook with this. Yeah. I'll cook.
Broccoli, pasta, butter mushroom. What would go good with tofu? Uh, Maybe I don't know. Would you would you consider using something like ragu sauce, or what do y'all try to use over there for the cooking substitute for the sauce?
Sauce. I mean, a lot of people have like stuff like oyster sauce, black sauce. I don't really use any of them. Yeah. What do you call that? Wagyu sauce?
Sorry, ragu sauce. That's what we use here in
How
the
do you spell
U.S.
it?
It RAGU and then sauce. But
Like
it's like
that.
a brand. It's like a brand sauce. That's what it is. Um,
Yeah, I think
but
it's
I don't
fine. You want to come up with another ingredient? Yeah, just to test this pipeline out.
see. I don't think it matters too much. I just don't want to give the LM a hard time. I want to make something logical. Broccoli.
Yeah.
So we have the greens. We have our
Uh,
fiber.
we can do something like quite
Oh,
drastic. Like
pepper. We need pepper. That's what we need. We should probably
yeah, we
consider some pepper.
we can do something like M&Ms, like other stuff that is not very like typical. We can also do it, but it won't be chosen because it's like healthy. But we can change it later. Yep. So you can ask it to use like I don't know, egg. Okay, let's just try this and see what happens. So first, it will generate the recipes, and the recipes are like chilled tofu and broccoli pasta. All right, mushroom ragu pasta with tofu crumbles, creamy ragu. I feel hungry already, right? This is, yeah, actually, people use this to do creative stuff, and like you can ask it to generate like in a structured way like that to guide the LLM to like, hey, check which one has nutritional value and so on. So over here we can have even the healthiest ingredients out, but we can also see the entire list of recipes as well. If you would like to, you can see this is the entire list of recipes as well. This and their nutritional values like broccoli and mushroom omelette. Yeah, sounds nice. Okay, I wonder why tofu is ranked lower. Yep. Okay. But if you have like uh, some table that measures nutrition. Let's just generate that table right now. Generate me a table that actually we could get this one to generate the nutritional value, right? So include the nutrients for each ingredient used. Yeah, you can just put this here, and then we can see like whether it improves. Or if a reference table, like a lot of times people do pipelines, so you have see over here we have rich in vitamin C and fiber and so on. Yeah. So and you should put the nutritional value after the explanation so that by chain of thought prompting it would get the nutritional value. So over here, low in calories and ragu sauce. Doesn't look very healthy, ragu sauce. Can be high in sodium and sometimes sugar.
Hey man,
Okay.
that's the US for you, man. That's how we love it. Big and greedy.
Yeah, so you can see over here, this is the stuff. And this one looks like the healthiest egg drop soup and so on. So you can see that, okay. Right, so the plan over here is healthiest recipe, which is, what's the healthiest recipe? Let's check it out. It's broccoli and mushroom omelette. Actually, I thought it was the previous one. I thought it was this drop soup tofu. There's more than one, is it? There's more than one. Yeah, there's more than one five. Yeah, no worries. Yep. So we have all these recipes here. We can even see the healthiest recipes. Yeah, I might just provide this notebook so that if people want to cook, they can use this to help themselves to cook. So yeah, you have this skeleton plan is prepare ingredients, cook main components. Okay, so I realized a small issue here. The skeleton plan omitted the recipe itself. So, we might need to put back the recipe here. Yeah, so something like that, and we are all set. So this is the skeleton plan, which is kind of not very helpful. General outline skeleton plan it with the steps needed. Let's see whether it gives a better skeleton plan. Much better, you see, much better. Yeah, so the prompt matters also, you see. And then after that, we have this cooking the recipe and so on. And we can see the final recipe with this prep ingredients. We have broccoli, tofu, and this. Now we have this. Heat the pan, whisk the eggs, season it, plate. All right. So, let's just compare to see like if we were to just take these ingredients directly and, just ask the LM to generate something. So we could ask the LM is called LM. Generate me detailed steps to cook something healthy using the ingredients provided. And then, we can ask the ingredients here as the user prompt. And this is basically just calling the LM itself. We can generate this. And yeah, I mean, it's possible to do this also. It's just that, if we do it in a structured way, it might be much better. Okay, over here, we can definitely set aside the M&Ns. Okay, right. Okay, what are they cooking? Ragu pasta bowl with this. Yeah. So yeah, this is the stuff that it's very hard to read this. Let me just print this out. Comparison to getting LM to generate directly. Okay. So is the steps actually generating it directly not too bad also, yeah. Just that, if you want to do something like ensure that it's healthy and so on, you may not be able to get it as well if we were to do it like this. Yeah. So yeah, I mean, LMs are actually good enough to do this at the entire step. But if you do it in steps like this, you can actually get it to reason over like whether it's healthy or not and so on, which it can get you better output because like if you slice a pipeline into small little steps, this actually can be very, very useful. Yeah. And yeah, I think structured output is very helpful to do this because then you can ensure that output fits in a certain format that you like. Yeah. And so yeah, this is more or less how we would do it. And yeah, if you want to do stuff like getting the LM to use a tool, next time I will have an extension to this where you can put in the functions and then you can output the function itself, or you can execute the function and return you the answer. Yeah, not a problem. It's like an agentic structure, just that you know, we try to make it as bare bones as possible because I realized in my agentic framework, Agent Joe, like the more you prompt it to do certain stuff, like use the tool and so on, it's very specific to the model itself. It's not very generalizable. So I prefer if the parser itself just return you like what tool to call, something like function calling. Like if you look here, yeah, something like function calling, you can just print out what functions to call. and then you call it yourself. I think that's better. Yeah, so I quite like this kind of stuff. Just that I don't really like to create all this. So if let's say there's a way to automate this, which there is, you can actually automate a JSON schema building with some decorators and so on. Yeah, so I think something like this is actually enough already, compared to agent frameworks, I realize. Yeah, because a lot of times, especially during work and so on, I realized that the best way of doing stuff is still pretty much a LM-based pipeline rather than a full-blown agent to handle everything. Because it's just more reliable to just go through this pipeline, like how I did here for the recipe. Yeah. Okay, I hope this was to your satisfaction. I don't know whether you want to put your own ingredients and test out, yeah. But this is how I would do it for like structured output pipeline.
No, I liked it a lot. The typing out the step-by-step reasoning. But the YAML is really it looks really easy to type out. It doesn't look harsh on the LM at all. It's
Oh,
very readable.
you mean this one?
Yeah,
Or
yeah.
mean the earlier version that you saw like here? This
No,
YAML
no,
here.
no. For the coding session we just did, this one, the recipe one. Um, the YAML looks pretty nice, especially with all the backslashes. It's very easy to parse it out and have a very readable text. It's not like a lot of delimiters or brackets you have to deal with.
Yeah, I think this one JSON will work also for this example. Yeah, it's more like if you want to do a code. Just now the code didn't really work too well because we don't really have the context for this thing here. We need to pass in this one and say that this is like recipes equals to this, or you have to take in a variable recipes and come out with some code to manipulate it. Yeah, I think need to prompt it more. For those kind of use cases, YAML would work very well. Yeah, if not, actually JSON, I think JSON works very well for this as well.
Okay, makes sense.
Yeah. Okay. Yeah. I think that's about it for today. Unless you want to see something else, like I think this is more or less. Maybe I do one last thing here. Like so, that's a primer to action based code. Action based agent. So let's say if you have certain functions you want to use. So like for example, you want to add numbers. A very simple thing. Okay, int, you have x and y, and then you just return x plus y, and then you have like subtract or multiply numbers. Okay, so here we can just copy this and put into the agent, right? So like pass YAML, you are to evaluate something like that. You have access to so you can do something like this. You have access to the following tools. Output a list of steps to perform the calculation, something like that. Yep. So like we can do this is the system prompt. Of course, we shouldn't output the entire function inside here. We should just like maybe put the description. So like the user prompt would be, yeah, is there an equation? Okay, so the user prompt can be the equation is this. Yeah, you can just put in your own equation here, and then you can put the output format would be, you know, list of two calls. Okay, and then like you can do this format again. You can just basically say to name and then your two params. Okay, so we can have this here. This is in the form of define to name, two params, and then maybe like the output. Okay, so maybe here we could just okay, maybe we don't even need the definition. So something like that. Yeah. So we know that this is the tool name and these are the two params, okay? And yeah, let's see whether this works. And yeah, I forgot the invalid syntax system prompt. Oh, okay, so we have this. Okay, so what we can do for rest list of two calls for two in this. Okay, so what we can do is we can, oh, so actually they already calculated this here already. So, maybe what we can do is we can like reply user as one tool. So we can put reply is a string. Okay. You can just put like output the next step to perform calculation. Because over here we call the tool is like kind of cheating because we already have the answer. And with reply user, something like that. So this is how like stuff like Crew AI does it. Like, so you can just do something like this. Very, very simple. I'll put something like this in PassYAML soon that you can just take in this and then you can output like with some template here already pre-pended for you or pre-made for you, just plug into your LM call. So you can do like that and you can just do like a two call. Like maybe over here is okay, previous steps. You can do like over here, you can do like the history here. Yeah, so I'm just live coding how an agentic system would work. So we have a history here which currently has nothing. And yeah, so maybe we also need to define the reply user here because return reply. That's all. Yep. So okay, we can end on reply user. So we have this. Okay, so what we can do is for we just repeat this 5 times, do this pass YAML. Okay. Um, then we take these two calls here. So okay, exact rest two calls with these parameters here. So you could just call the two calls with the parameters. Uh, so I can't remember how I did it in the last one, but you can just see whether this is in add numbers and so on, and you can call the add numbers too. So we can just do something like this. Two call equals to rest two calls. If two call is add numbers, okay, history.append add numbers, you call that add numbers, and then you have the params also. Yeah. Okay, then we basically call the result. Maybe you can call it tool result. Yeah. So this is basically how you do your agentic loop. Yeah. So you basically call one by one. I mean, here I just do here. I'm sure there's a way to do it in a better, but let's just call multiply numbers here and then here apply user. Okay, if not we just break. Okay, because we don't want anything to result equals to this, equals to this, and equals to this. And yeah, there should be also a way for you to check whether the params match this one. Yeah, so there are different things that can be implemented. But all in all, I think something like this, which is in like something like Agent Joe, you need to actually expose more of this to the user because sometimes you want to prompt it better. So this is what we'll do here, and then we will append the history. And we'll append in this history. Okay, we append the result for this as well as the tool result. Okay, so okay, so here, okay, maybe we just do in a F string. So tool call will be this, and then the tool result will be this. Something like this, and yeah, we could just probably print this. um, turn turn result. We can call this turn result and or step result. Yeah. And we can probably print this step result. And yeah, we can append this in our history. Okay, let's just run this and then okay, we have a two error, two params is not there. Okay, let me see what's wrong. Okay, two name. Oh, because it's under two calls. Okay, so actually we don't need this anymore since we are using the simplified version without the we can just output this two names, two params in the output format as easy as this. Okay, then we should have everything we need. Okay, and then we don't have two calls now, so it's got two name and two params. Okay, I think this should work already. Okay, so we have two call, multiply numbers, add numbers. Okay, so once we do this, we should actually break. So first one, we have two call as this. And then we need to have two params also. Two params is here. All right, let's see what step one, multiply and two. Done. And then we probably should have the last call, which is reply user. Okay, which I think I didn't print out. We can just print out reply is this. Or we can have this function print out. Yeah, we can have this function print out. All right. The answer is 38. So yeah, yeah, this is basically how you do a simple agentic loop. So I want to automate this whole thing here, but I still want to expose this part to the user as much as possible because I think there's a lot of things that can be done here. You can have extra parameters here and so on. So this is how we would do like using parse YAML to get a tool call using structured output. We just ask it to output the tool name and the params, or you can even output the list of tool name and params if you want to do it in sequence without calling this again. This could be like a planner. But in this case, you can't do it sequentially in this with the params like that because you need to first do the like multiply before you can add, right? Like if not, you can't do this. Like so, if you were to do something even more complicated like this, like you kind of need to know like what's going on before you do. So here's okay. So over here, 3 plus 5 times 7 is somehow new is 38. I have no idea how it does that. Oh, I forgot to reset the history. No wonder. Okay, so yeah, you can see that now it's and there we go. We have the answer is 62. So and just like that, we have created an agentic loop just using parse YAML. Right, of course, you can do strict JSON as well. I'm just showing you like how you would do structured output to get an agentic loop. Yep. And yeah, you can even see the history is here. Is the history. These are your two calls and your two results. Just like that. Very simple. Like you can use this to do deep research as well. If your two call is getting some website, you can return the websites, the top 10 websites in Google, return the summary and so on. You can put that in the history and then the agent can then search another query and so on. And at the end of it, you can call a LLM to summarize the results. Yeah, that's how we do deep research agents, just doing a simple structure like this. Okay, I think yeah, that's more or less what I wanted to show for today. Any last words before we end? All good? All right. Yeah, if not, thanks for coming. Yeah, and hopefully this was useful. Yeah, do try out Pass YAML. It may not be like 100% able to pass everything, but I'm sure it can pass most things that are useful. Right? You can use very, very flexible data structures as well. All right. Hope you try out and let me know how it is. Okay. Thanks everyone. Bye.